Hello everyone, thank you for tuning in to this workshop presented by Code Labs Academy. In this workshop entitled Beginner Kaggle Machine Learning Competition, we will see what Kaggle is and how we can participate in a Kaggle competition. And throughout this workshop, we will be building a project and we will see the different steps from data pre-processing to creating the model, getting the results, and submitting the results that we got. So the first thing that we're going to talk about is Kaggle. So what is Kaggle? Basically, Kaggle is a website where we can find competitions to solve data science problems. It also allows the users to find and publish datasets. And one of the main advantages or one of the main strong points of Kaggle is that it has a very large community. Therefore, it is the ideal place to start practicing data science skills for beginners. As for what we will learn today, we will see how Kaggle competitions work. We will explore, analyze, visualize, clean, and prepare our data. After that, we will build a machine learning model using scikit-learn and tune these models. And we will also see some of the best practices for Kaggle competitions. And finally, we will see how we can submit the results that we got. So this is the homepage of Kaggle. Basically, this is the first thing that we see when we go into the website. Obviously, if you don't have an account, you have to create one. So feel free to do so, then continue with us. Basically, Kaggle has a lot of features. We can see them right here, such as the competitions, the data sets that are published, the code that is published by you or other users in the website. There is the discussions section in which we can access informational discussions posted by the Kaggle community, and there are also some courses that are provided on the website. Like we said earlier, we will be participating in a competition about Titanic. So let's look it up. Right there it is. So we can access it. Basically, when you enter a competition, there are a lot of information that you can find about it. So first we have an overview in which we have the description. So you can check this if you want. You can find a description about the challenge, overview, how to join, how to work with data, and all of that. So feel free to check this on your own if you want. There is the data section in which we can find information about the data. So as we can see, the data has been split into two groups, training set and testing set. So this is already a good thing for us. And we can see a section in which the different variables of the data set are presented. So we can find the name of the variable, its definition, and the keys if it has any. We can also see some explanations here in the variables node. And here we can find some of the rows of the dataset. So the first one is a submission. We're not interested in it. We're more interested in the testing and the training set. So if we check the training set, for example, we can see here some rows of the dataset. There is this passenger ID, variable, survive, p-class, name, and etc. So you can see all of the variables alongside some useful information about these variables. And what we can do also is if we want to work with this data set locally, we can download it and use it on our personal machines. Also, there is this code section in which we can find some code posted by the users and even our code after posting it or submitting it. We can find some discussions. And also there is the leaderboard in which we find the scores of the users that have submitted. So here we can find the first people have got 1 score, which means that they created models that were able to correctly classify all of the testing set. And we can see how many entries these people provided. And finally, we have the rules of the competitions. It is important to check the rules if you're participating in a tournament, because sometimes there might be some restrictions on what you can and cannot do. So yeah, Basically, you have to go through these before participating. But for now, we will just directly start coding. So what we can do is go to code, then your work, and start a new notebook. So this gives us an access to a notebook online, of course, on the platform. And the first thing that we can notice, and let me just make this smaller. The first thing that we can notice is that there is already a cell in the notebook that we just created. So this comes directly with the code. So this is like it just imports some of the packages that are usually used in data science project, like NumPy and Pandas, for example. And there is also a line that lists the files on the input directory. So we can run this cell. It takes a few minutes because we are starting the session, so we have to be patient with it. Once the session starts, we can keep on working. Perfect, so we can see that the session has started. We can run the code, but nothing has happened yet. So what we have to do is to add data. We can go to the competitions data right here and look for the Titanic. There it is. This is the competition that we were participating in. So we can just add this data set. All right, perfect. So it said that Titanic is ready to use. So we can run this, and we can see that in the directory now we have the training set, the testing set, and the submissions that were included in the competition to give us an example to follow. So basically these are the 3 files that we have for now. Now what we can do, or the first thing that we should do, is to read these files. So we can create 2 variables, train data, in which we do pd.read csv, and we provide the name of the training. So we will just copy and paste it. It is simpler this way. Then we create another variable for the test data, and we read the second file, and then we can run these 2. Yeah, so this was a mistake that was made right here, so it should work. Perfect. So we have ran that cell. So what we can do is to check the information that can be returned from this that we can access in this data set. Yeah, so basically this was not a code cell, so we'll just delete it. Now we have the training data, we have outputted the info, so we can see the different variables alongside the non-null variable count, and we can see the type of each variable. Alright, so we can notice that most of the attributes have no null values, so this is actually a good thing. So the attributes with null values are age, cabin, and embarked. So these are the variables that have null values. So for embarked, there are 2 null values only, And for age, there are much more. And for cabbing, most of the data is missing. So we will see later how we can deal with such missing data. Now, let's use the describe function to display some stats about our numerical variables. So we can create a cell, and we can simply use the describe function. All right, we can see the result right here. So for each attribute, we have the count, mean, standard deviation, minimum, maximum, and the quartiles. Alright, so looking at these values helps us understand our data, which is very important in any data science project. For example, by looking at the quantiles for where is it? This variable right here, the p-arch variable, or I don't know how it is called. So I believe that this one refers to the number of parents and children. So we can see that most of the passengers have 0. All right. And we can also notice that 38% of the passengers on the train data have survived. There it is, right here. And there could be many examples of outlier values, such as negative fair values or very large SIB values. Now let's explore each variable separately. We will first want to separate our numerical variables from the categorical ones. So using the describe function combined with the columns attributes of data frame is one of the cool tricks to do this quickly. So let's try it. So we can do train data dot describe, so which is basically the previous line, but we will use columns on it. And then when we run the cell, we can see the numerical data. So the passenger ID variable brings no information since it's unique for each passenger, so we won't be using it. So the survived and p-class variables are numeric, but we have to consider them as categorical variables, as they represent categories. For survived, it's obvious, a passenger either survived or not. As for the p-class, we can check that by displaying its unique values using the value counts function. So we will be doing that real quick. Train data of p class, I believe this is how it's, yeah, p class dot value counts, and we print it. Yeah. So there are basically 3 different categories. And now what we will do is that we will create the different data frames. So we will create dfnum for the numerical values. It will receive trained data of age, sp, porch, and fair. As for the categorical, it will also receive train data, and we will be filtering by survived, p class, forgot the quotes. All right, p class, sex, ticket, cabin. So all of these are categorical variables. And finally, I believe it was embarked. We can run this cell. All right, perfect. I think that the separation has been done successfully. What we can do right now is we can visualize the distributions of our numerical variables. So we can use a simple for loop. Num.columns. And what we can do is to use plt.est df nums of I, and we can add the title using plt title, and we add I, which is the column, and finally we have to use the show function. Alright, so there is an error. Yeah, we haven't imported the library yet. So import matplotlib.py plot as plt. Alright, there is df nums. It's dm num, not nums, but not with an s. I think that this should do it. Yeah, as you can see, these are the different distribution of the numerical variables. Feel free to check them. So basically, this gives us a general idea about the distributions of our variables. For the fare, for example, we can quickly notice that most of its values are less than 50. What else? So now let's take a look at the correlation matrix. So basically the correlation matrix can help us spot if there are any linear relationships between our variables. It uses the correlation, which is based on the calculation of the covariance between variables. So we can just simply use dfnum.cor, which is the function used to output the correlation matrix. All right. So we usually, as you can see, this isn't very readable, and in cases in which you have more variables than 4, which is our case, we usually use heat maps to visualize the correlation matrix. It helps us spot the high values more easily, especially, like I said, when we have big values. So we will be using Seaborn. Alright, so we can use its function, one of its functions, which is a heat map, and we provide dfnum.core for the correlation matrix. Alright, so we can run this cell, and as you can see, this is already more readable than the previous one. Like I said, it is a better way at visualizing correlation matrices. So we can see that there is some correlation between SIB-SP and the bar CH, which makes sense since these two variables are somehow related to each other. And now let's check the average value for each of these variables for passengers who survived and who didn't. So basically, to do this, we use the pivot tables, and we'll be using the pivot table function. So it takes the data frame as a first parameter. The index will be the survived variable, and we'll be selecting the rest of the variable as values. And we use the mean as an aggregation function as we want average values. So this gives us an idea about the distribution of the values based on the fact that a passenger survived or not. So to do so, we will be using, like I said, the pivot table function. Train data as a first parameter. As for the index, we will be using the survived. As for the values, we'll be using age, SIB-SP, what else? Porch. So this is actually for the parent children, and finally the fare. As for the aggregation function, we will be using the mean. Yeah, I believe this is it. So now we can execute this line, and we can see that the average age for passengers who survived is lower, and also the fare is higher, and the number of parents and children is also higher. And finally, the number of siblings and spouses is lower, because the variable SP is for siblings and spouses, all right? And we can see that the average age for passengers who survived indeed plays a role. So this actually gives us more insight. Now let's move to the categorical variables. As we did with the numeric ones, let's plot the distributions of each of them. And obviously we'll be using also a for loop for I in df cat dot columns. What we will do is we will be using the bar plots from Seaborn. For the x value, we'll be using df cat of I dot value counts. Dot index. So this will be our x, and for the y we'll be using df cat of I df.I, and we use also value counts, and we will be doing, just 1 second, yeah, and I think this is what should have been done. And we have to set the title. Actually, we don't have to. It will be just more readable, and we will put it as I. Perfect. So we have what is the issue? Alright, so we have the SNC bar plot. So we have for embarked, but we should have more than that. We should have also for the previous values. Let's try to run this one more time, just so that we make sure nothing. What we forgot to do is to use plt.show, because if we don't use plt.show, it will only show the last one. I'm sorry for that, so let's run it. There it is. That's way better. Now we can see the different. Yeah, it's still running, so let's let it finish running, then we can discuss the results. Alright, perfect. Now it is done. So what we can notice is that for cabin and ticket, which are these two graphs, there are a lot of categories, and it won't be efficient to apply machine learning directly on such data. So this is an area where we might want to do some feature engineering. But before moving to feature engineering, let's finish with exploring the relation between the survival and other categorical variables. As we did before, we will use the pivot table function to do this, but this time we are more interested in the counts of each category for each variable. That's why we will use the count as an aggregation function instead of the mean that we used in the first place, or in the first part. All right, perfect. So what we can do is to use pd.pivot table, same as before. We use the training data. As for the index, it will be survived. All right. As for the columns, let's start with them one by one this time. Let's correct this real quick. As for the values, we will use the passenger ID, and for the aggregation function, like we said, we'll be using the count. So we can run this. There it is. So basically here we can notice that the survival rate for women is much higher than the one for men. It is obvious right here. All right. Now let's do the same thing, and this time we will do it for the column embarked. So let's just copy and paste this and change the column to save some time. All right, let's go down a little bit. Yeah. So here we can see that the city from which the passengers embarked also plays a role. So the survival rate for Cherbourg is higher than 50%. However, it's lower for Queenstown and much more lower in Southampton. So these are the three main cities from which the passengers embarked. They are identified as C, Q, S, C for Cherbourg, and Q for Queenstown, and S for Southampton. So now let's move to feature engineering. Basically, we will start with the cabin variable. So the first thing that we should do is to explore its values. If you remember, what we checked first is the cabin variables had a lot of null values. So what we should do is to check the non-null values and how they look like. What we can do is to use df cat for categorical variables. We put df cat dot cabin dot not null, and we can use dot cabin to get the values of the cabin column, and head to get some of the rows, and let's put 40. All right, so these are all right, there it is. These are some examples of the values for the variable cabin. So we notice that there are some passengers with multiple tickets, like this one right here, number 88. So now let's create a new variable that will contain how many tickets a passenger has. So this, in this we will consider that null values means no tickets, and it will be easier to handle. So what we will do is to go to df train data, that's what we called it, and we will call it cabin multiple. What we can do then is to do the value of train data dot cabin dot, and we will apply. So basically what apply does is that it applies a function on all of the rows that are concerned with this request. So basically we can define a function above and use this function in the apply method. But instead there is a more elegant way to do so, and it is to use the Lambda functions. For those of you who don't know how to use Lambda functions, it's not a problem. Like I said, you can just define a regular function and call it inside of the apply method. So, sorry. Yeah, so we will use x, and we will say that it will be 0 if pd dot is NA of X. So because if it is null, then it will give it the value 0. And we will say also else we will take the length of x dot split, and we will split following the space, because we have noticed that when people have multiple tickets, there is a space that separates the names or the numbers or the identifiers of these tickets. So when we split it following the spaces, we will get an array in which each element is a ticket. All right. And finally, what we will do is that we will see the value counts for this new variable that we just created. So we can just do train data, cabin multiple dot value counts. I've written it in the wrong line. Dot value counts, and this should do it. All right. So here are the different values along with their frequency for the new variable that we just created. So let's now explore the survival rate for each of those values. And obviously to do so, we will use what we have used recently for the previous cases, which is the pivot table. We will give it the train data, and we will give it the index of survived, like we just have done. And for the columns, it will be the new variable. And what is missing from this? Yeah, the values. Yeah, so for the values, we will use the tickets. Let's just write values right here. Values, we will use the tickets, and the aggregation function, which is the last parameter, we will use the count. I think that it looks good. Let's try to run it. All right, so we notice that the more tickets a passenger has, the more he is likely to survive. So the feature we created may be useful for our model later. All right, so now another variable that we can create is the first letter of the cabin. So basically, we will create another variable, train data dot cabin, well, not this one, let's call it ADV. All right, now what we can do is to use the train data dot cabin, and what we will do is we will use the same function, which is the apply function, and we can do a lambda, I always forget the parameter, and we will use the string function on x to get basically to transform x from a what was it? It was, I believe, a list. Yeah, cabin was a list initially, I believe, and transform it to a string. Then we get the first element, because that's the first letter of our cabin, and this gives us information about the location of the cabin, because there are cabins that start with C, so they are located on the same area. There are ones with F, ones with A, and etc. So we run the cell. I think that it has been it was run correctly. All right, so what we can do is to see the variables count for this new what do we call it, variable, which is cabin ADV. So we can start with train data dot cabin ADV, yeah, value counts, value counts, and this should do it. We can print it. All right, so here we can see that there are a few cabins, N, C, B, D, until T. So these are the available cabins in our data set. What we can do also is to print the pivot table for this new variable. You should have memorized the command by now, which is pivot table, train data as a first parameter, index of survived, what else, columns. We will use cabin ADV as, what else is missing? We can use for values the name, and for the aggregation function we will use the count. Let's run this cell. I think that we have an error. What was it? Name. Yeah, I think that name starts with a capital N. Let's try once again. Alright, I believe that it has been that was successfully executed. One thing that I believe happened in this line is that N was used for the cabins with null values. Yeah, so this makes sense since most of the passengers didn't have a cabin. So yeah, we can see that there is a difference between the survival rate of each letter here in our pivot table. So this will also probably help our model. So now let's try to understand the ticket variable. And what we can do is to start by visualizing some random values. So we use train data dot ticket dot sample, and let's do 20. Execute this. All right, so we notice that there are a lot of tickets that are composed of numbers, letters. So let's try a variable that tells us if a ticket is numeric or not. So train data, let's call it numeric ticket. It will receive train data dot ticket dot apply. We will use also a lambda function, and what we will do right here is that we will check if it is numerical or not. We will say that it will be 1 if x dot is numeric, which is a pre-built function in Python. We will say else 0. We execute this cell and it should have worked. So now let's check the pivot table. So I'm just going to copy and paste it. Alright, so this is the pivot table that we got. So we can see that the people that had a so basically we can see that the number of people who had non-numeric tickets didn't survive as much as those who had. So basically I believe that in this case there isn't much to deduce because the ratios are pretty much the same. Now the last feature engineering thing that we're going to do to perform, it will be on the names. So we will extract the title of the person since it may affect the survival rate because the names have titles in them, and we can check so quick using train data. Or let's use it like this and use head, and let's display 50 for example. As you can see here, we have Mrs., we have Mr., we have Mrs. So there are a lot of honorifications in here. What else? Do we have something else? Yeah, so there are lots of Yeah, so there are lots of titles. This can also, like I said, this can be helpful for us. So we notice that there is always a part of the name followed by a comma. Then we find the title. So this, and the title, it always ends with a point. All right. And then after the point, we find the rest of the name. So we will combine some splits to extract that title. So train data dot name title receives train data dot name dot apply, which we have used a lot, lambda x, and we will be using x dot split, and the split will be first by the comma that we have just identified. So let's specify it, and then we will be getting the second element because the first one is the first part of the name. And after getting the second part of the name, which is the title plus the rest of the name, what we will do is we will also split following the point, which was the at the end of the title, and then we can get the first part of it, and the last thing that we can use is the strip method to get rid of the white spaces. All right, so let's run it. And what we can do is to check what we have generated using this function, which is just value counts, to see what are the different possible values for the title. As we can see, there is Mr., Miss, there are other things such as doctor, what else, lady. These are some of the examples that we have. All right, so we are done with the exploring of the data and the different feature engineering that can be performed. Now it's time to prepare our data set for the model. So we start by combining our train and test set, so that we can apply the transformation only once, and we add a variable named train so that we can use it to split later on after the different operations that we will apply. So let's use train data of train, and we will give it 1. We will do the same with the test data. As for the test data of the variable survived, we will use np.notAnumber, and finally we will be merging all the data with pd.concat to concatenate both of these. And then we will be using the two data frames, which are train data and test data. All right, so now what we do is all data.head to see what we have got as an output. All right. So now what we should do, since our data is now 1, since we combined the two data frames, is we will apply all of what we did before to our data set, meaning the number of cabins, the first letter of the cabin, whether the ticket is numerical or not, and we extract the title of the names. So since we have already seen how that is done, so we'll be just copy and pasting it. Feel free to take some time to see how you can sort it out, or to pause and see how you can do it, but this is basically it. Just the same operations apply to all data. All right, so now we run it. What we can do now is to check for the information of all data. Data.info. We run it as well. There it is. So basically, we have to then impute new values with the median for continuous data. So what we do is all data.age, it will receive all data.age dot fill na the train data dot age dot median. And now we will do all data dot fair, and it will receive all data dot fair dot fill na. Believe that fill na doesn't have, yeah, it should be like this, fill na, and we will give it train data dot fair dot median. There it is. We execute, so this should do it. And now for the variable embarked, there are only two null values, so we can simply drop them. And to drop them, it is fairly simple. We'll be executing this following command, which is all data dot drop na, and we will say subset equals embarked. After that, we have to specify that in place equals true so that the changes take effect on the current data frame. We execute it, it should have been successfully done. And now what we can do is to count one last thing that we can do is that for the P class, it has an integer type, but we want it to be related or treated as a category. So we will have to cast it into a string, which is also simple. So what we can do first is to check the different possible values. So all data, P class dot value counts. We execute it. We see that there are three possible values. So what we can do now is all data, where was that? Yeah, dot P class receives all data dot P class, and we cast the input or the variables, the values. All right, so now that we casted it, we will be using the getDummies function to do one hot encoding automatically to the categorical variables, except for the target variable, of course, which is the survived. So to do so, this is the syntax. So it is simply all dummies receives pd.getDummies, and we use the all data and then all of the categorical data. You just have to write them one by one, and this is pretty much it. So now we execute this cell. All right. And finally, our data is ready. So let's check it again. Let's do all dummies dot info to get information about it. All right. As you can see in this data, there are no new null values, and much more variables have been created due to one hot encoding. All right. So finally, we split the data again so we can train our model and predict later the labels of the test data. So we do x train, it will be equal to all dummies. We will be filtering with all dummies dot train equal to 1, and we will then drop the variable train. Let me double check. Yeah, and we have to specify in the drop that we will be dropping from the columns. So we use axis.1. We'll be doing the same, so let me copy and paste this real quick. And what I have to change is that here, instead of train, it will be test. And yeah, here it will be 0. And drop train, I believe that it's, yeah, it should be the same for everything else. So we execute the cell, and we can get the train label from the previous variable all data using the filter train equals 1 and selecting only the survived column. So let's do it. Y train equals to all data. We will filter by all data dot train equals to 1, and we will get only survived. And what we can do is to check the shape. Y train dot shape. It's executed. All right, so we have 889 instances. And now, last step before building the model is scaling the data. So we will be using the standard scaler from scikit-learn to do that. Then we scale all the numeric variables. So scaling is important if we are planning to use a machine learning algorithm that calculates distance between data points, such as SVM, for example. So first, let's import it from sklearn.preprocessing import standard scaler. Sounds good. Then scale is equal to standard scaler. Yep. Then all dummies scaled. So basically we'll be creating a new data frame that contains the scaled variables. So we will be just doing all dummies dot copy. This will copy the data. Let's go down a bit. So now we'll be doing all dummies scaled, which contains a copy of the data, and we will be filtering with age, sibling, spouses, which is sib_sp, parent, children, and fair. They will be equal to scale dot fit transform, and we will be giving them the same thing that we use right here, which is all dummies scaled and then the name of the variables. All right, so let's do this. All right, and we will do also the same with xtrain and xtest. So let me just copy and paste it, but you can make sure that we are doing the same thing. So basically we're using all dummies and we're transforming it into xtrain and xtest, which is what we did right here. So we can run this. It has been run successfully, I believe. So what we can do then is all dummies scaled. We can use age. Let me just copy and paste it. Yep. And what we can do is to describe these so that we would know what the scaling has done. So we can check that the mean of these variables is 0. What is happening right here? Yeah, I think that I didn't put the parentheses. Yeah, because the effect of scaling is that it returns the mean close to 0, and this is what we can notice. And the standard deviation is almost 1. So these results are not as sharp or as precise as we want them to be, but they are really good. The mean is almost 1 and the standard deviation is almost 0. So now we can start building our model. So usually in machine learning competitions, we test as much models as possible and we spend a lot of time tuning them. But because we are limited by time, we are going to test two algorithms only, which are the random forest and SVM. So first, we start by importing these models from scikit-learn. So from sklearn.svm import svc, and from sklearn.ensemble import random forest classifier, and we will be also using cross validation, so let's import that as well. sklearn.model selection import cross val score. Let's run these. Alright, so they were imported successfully. So first, let's start with the SVM classifier. An approach to efficiently test a lot of models is to start with the default with default parameters for each one, then we compare their performances. After that, we select the best ones and tune them. So we test on the non-scaled data first. So we use SVC, it receives SVC. And after that, what we will do is to use cross validation. We use SVC, then X train. This is obviously the non-scaled data, and then Y train, and we give it CV of 5. Then we can print CV, and we can also print CV.mean to see the mean of the results. We can then run it. Alright, so the accuracy is roughly 67%. So let's check how scaling the data is important for the SVM classifier, because like we said, scaling is important when we have models that are based on calculating distances. So let's do pretty much the same, but we will use the scaled versions of the X train. So I'm just going to copy paste it, but you can see that it's the same thing. The only difference is right here. There it is. Yeah, so all right, so let's run this. All right, so now the average accuracy is 83%. So scaling the data helped a lot. Now let's check the results that we can get with random forest. Let's call it RF, short for random forest. Let's call it random forest classifier. We will give it a random state of 1. So this is more of a seeding. Now CV for cross val score, and we will give it RF, we will give it X train, and we will give it also Y train, and we will say CV equal to 5, and then we will print both of these like we did in the SVM classifier. All right, now what we can do is that we can run this cell. We can see what we will get. So basically the score that we got is roughly 80% accuracy, which is really good. And what we will do now is that we will try the same thing with the scaled data. But remember that random forest doesn't rely on what do we call it, distance measurement like SVM. So we shouldn't notice a difference. Yeah, so there is a slight difference right here, but the accuracy is also roughly 80%. Yeah. Now let's try to tune the SVM classifier, since it returned the best results. So first we will be using grid search to get the best parameters. So from sklearn.model selection, we can import grid search CV. can run this. All right, all good. As we don't have a lot of time, we use a very small range of parameters. So usually people try much more values for all the possible parameters. So we will be building a parameters grid with two parameters. Kernel, for which we will try the RBF and linear values, and C, for which we will try 0.1, 1, and 10. We then create a grid search instance. Let's start by applying this already. So svc, then param grid. We will say that we have kernel. It can either be RBF, yep, or a linear kernel. We also say that C can be equal to 0.1, 1, or 10. So we're using a logarithmic scale. Alright, so now we will be using a classifier, svc classifier. We will do grid search CV, and we will give it the model, the param grid CV equal to 5. We will say that verbose is true. I believe that this is pretty much it. Yeah, also for the number of jobs, we will give it -1, which means that we will use all the possible processor scores. Alright, so let's run this. There is an error, name param grid. Yeah, param grid. This should do it. Let's run it one more time. So it's running. Don't know if it returned results yet. Yeah. What we didn't do is that we didn't fit our model. So let's use best CLF svc, and we will use clf.svc.fit. We'll use x train. Let's use the scale because we said in SVM it is better to scale data, and then we will use y train. Alright, let's start. So now it is running. Perfect. So fitting 5 folds for each of 6 candidates, totaling 30 fits. Now what we will do is that we will print the best scores and the best parameters that are returned from using grid search. Alright, so let's print. Alright, so we got 83% accuracy. So the result isn't very interesting, as there are the same, and the default parameters used before, there isn't much of an improvement. So if we used larger intervals and tuned all the parameters, the score would certainly be improved. And yeah, you can try it on your own if you want. So now let's use the best model returned by the grid search and predict the labels of the test data. So y test equals best CLF svc dot predict. We'll use x test scaled to use the scaled values and use as type int. All right. So now we have made the predictions. Now let's build the final data frame, which we will use for the submission, because as I told you, we will be submitting the results. So we have final data. We will follow the form that they required us to use. You can check it on the competition overview page. So the form is passenger ID. Let me just copy and paste it, then explain it, so just so that we wouldn't have any errors. Yeah, so we have passenger ID, in which we simply add the passenger ID from the test data and survive for the predictions that we have made. All right, and finally, we will be using submission. It's a variable called submission. We will use pd.data frame. We will give it data equal final data. All right, so this simply creates a data frame. What we do then is then execute this code, and what we will do is submission dot to CSV to create a CSV file from the data frame that we just created. Let's call it submission.csv. We will say that index is false. All right, perfect. So now we can execute this. Let's see. Yeah, so now we have the submissions. All right. So we can see here that we have a submission. We have 10 daily submissions to be precise. So let's just try to submit this this file that we created, which is called submission.csv. Let's click submit. Yeah, this is the version 1, which is the first thing that we have done. Let's just call it version 1 like it was. It is optional, of course, you don't have to. As for the description, you can also put whatever you want, and let's just submit it. So it is queuing, still running, so let's wait for it. Perfect. So what we can see here is that the submission has been done, which is good. So the score that we got is 77%, and this, which is our best score so far. So that is good to know. What you can do also is to check your ranking if you want. This is not required, but if you want, you can, yeah, you can check your ranking in the leaderboard. You can go to the leaderboard position. There it is. So we're 3,211. All right, so thank you for following in this workshop, and I hope that it was helpful to you. Please, if you're interested in these workshops, follow us on social media and let us know if you got a better score on the leaderboard. So until next time, stay safe.